Okay, welcome back. We're doing some drills to show, for example, if two arrays are the same. And the first thing you need to check is if their length is, and you can kind of assume that they are true until proven otherwise. All right? So in our example, I'm checking to see if junk 42 and 12 are the same. And if you recall, they should be because actually they're pointing to the same thing. So let's just run this. And it says, yes, 42 and 42 is true. Okay, now I've got my copy of thing working where I resized the array and now it's going to have 5 elements in it rather than the original 3. So I'm just going to copy this a second time and put it on the other side of this. And we'll try that one more time. And so now it says, no, man, they're not the same. Okay, so that's one of the drills that we just did. Okay, so calculating the sum or the average, that's pretty straightforward, right? I mean, in this particular example, I'm using sum. But if I wanted to convert this to average, all I'd have to do is just take return answer divided by the length, right? That'd be pretty good. So we've checked to see if the contents of 2 arrays are the same. So let's do one where you try to find the maximum value. This is kind of an interesting pattern, so kind of pay attention. So I'm going to do static int find max, and then pass it some array of integers, whatever that is, array. Okay, if you're hunting for the maximum value, then the starting value that I'm going to be comparing to is going to be a really small number. All right, so I'm going to say int answer, and so I want the smallest integer there is. Well, what is that? Well, to tell you the truth, if I said integer dot, one of the things is min value. So I'm going to pick that as my starting location. And then I'm going to say return answer like I always do. Okay, cool. So if I'm hunting for the maximum, I start with the minimum. Okay, good. Obviously, if I was hunting for the minimum, I'd start with the maximum value. Okay, am I going to be making any changes to the loop or anything like that? No. So the enhanced for loop would be just fine here. Okay, so we do for int value array. That would work, right? Cool. And basically all we have is an if statement that says, hey, if the value is greater than the answer, because we're hunting for the maximum, greater than the answer, then I want to set answer equal to the value. That's it. That's all we do. Okay, so let's try this guy. I'm going to go back up to here, and let's do it after the sum guy. So we say system out, yikes, print ln, the max is, we're going to use hip hip again. Oh, doggone it, behave. Okay. Plus find max, hip hip. Whoop. Okay. What did I do wrong here? Oh, I don't have a closing parentheses. Okay, let's try this thing. What is the maximum value in hip hip? Well, it's 65. Hooray! Okay, so doing sums and averages, checking to see if 2 things are the same, and doing mins and maxes, that kind of makes sense. Now let's do one where all I want to do is just check to see if something exists. So find it kind of a thing. And I have to have a special code here. And so I'm going to make up a special code for not found. So here we go. So I'm going to say static integer, and I'm going to call find it. And then I'm going to pass it an integer array, right? Okay, so my special code to indicate that it has not been found, I'm going to go ahead and just put this as a -1. Now that clearly is not going to work everywhere. This is just an example of how things work, okay? So don't freak out on me here. So integer answer is equal to -1. So if it finds it, I want to tell where in the array that it was found. Since -1 is never a valid array index, not ever, well then clearly that's an indication that something went wrong. So I'm going to do a return answer. Now, what kind of loop can I do here? Do I need to be able to look at the indexes? So, I have to have find it and then whatever the value is. The search value. Okay. So, if it finds it, it's going to tell you the array index. If it doesn't find it, it's going to tell you a -1. Make sense? Okay, cool. So I need a traditional for loop because I need indexes. Remember, the enhanced for loop doesn't have any indexes, so that wouldn't do me any good. So this is going to be the traditional for int index is equal to 0. Index is less than the array.length and index ++. And so basically I'm going to say if array sub index is equal to the search value, then the answer is going to be equal to the index. In other words, that's what I'm going to return. Plus, I can break. I mean, once I found it, hey, this is very similar to in English when someone says, I can't find my car keys, and they come back and they say, well, it was the last place I looked. And I'm thinking, really? You mean you didn't keep looking after you found it? Well, of course it's the last place you looked, because once you find it, you stop looking. That's what this does. Once I found it, there's no need to keep looking. I found it. I can stop now. So that's what the break does for me here. All right, let's check this thing out. So I'm going to go here and say system out println, and I'm going to say does hip hip have 12? And then we say find it, and we pass it hip hip, and we pass it 12. Okay, does it? To tell you the truth, I don't remember. We're about to find out. Nope, it do not. Let's go back up to hip hip and find something that is in hip hip. How about 22? Let's try to see if it has a 22 in there. So I'm going to grab this. And boink. Okay, so we just finished 3 or 4 drills on how to use arrays to accomplish things you want to do in an application. Like how to check to see if arrays are the same, how to find the minimum or the maximum, how to find out if something exists in an array, those kinds of things. And so yes, it's at array value number 2. Cool? All right. So we're finished with the drills. We'll get back to lecture. On page 437, they talk about this thing called partially filled arrays. And the idea is, maybe I don't really know in advance how big this thing, how many students I'm going to have. So I'm just going to put in a monstrously huge number like 400. And then have some sort of a marker in there. So I only have 30 students. But when you get to the 31st student, I'll put in like a -1 or some sort of a marker. And to tell you the truth, I don't do that very often. So I'm just going to table that discussion and we'll move on. Okay. On page 439, they talk about returning an array from a method. Like, hey, this is same old, same old. There's nothing really special here. I mean, I'll do an incredibly simple one that doesn't have, any real meaning. But so I do static, and I'm returning an array of integers, right? So that's how that works. And then, I don't know, some stupid thing. So then I'll just say int answer is equal to, cut it out. And then return answer. Now I'll confess, this method doesn't do anything. That's not the point. The point is how to get it to return an array. Well, all you have to do is put the return type in there as an array, and then your answer variable is an array, and then you return it. Like, oh, okay, dude, moving on. Okay, page 441, they talk about array of strings. Like, oh, okay, I think we got it now. I don't think we probably need to do that many of these. You know, really nothing to see here. I mean, the only thing weird here is, maybe weird, is using the dot operator to come up with extra things. Like, for example, let's say I say, oh, I'm running out of variable names, aren't I? I'm going to use junk again. So I'm going to do string junk 14. And I'm going to go ahead and just use the initializer because I don't feel like typing. So Bob, hey, ooh. Okay, I'm going to make this names. That'll make it make sense. So Bob and Sally and Joe. Okay, I have an array of names. Whoopee! The only thing that might be a little weird is when it looks a little strange when you ask for the dot operator, right? So for example, if I said names sub 2, which would be Joe, right? Dot, and then something. I'm going to use something like 2 uppercase. You know, just something, right? It just looks a little weird. I mean, it's not weird. It just looks a little weird. So this is going to be Joe in uppercase. Cool beans? All right. Again, move along. Nothing to see here. Nothing to see. Move along. Okay. On page 444, they talk about an array of objects. Like, this is not complicated, guys. We just did an array of objects because strings are objects. But just to drive home the point, I'm going to copy the rectangle guy from our chapter 6 into, hey, here's a good question. Can I just like grab this guy and like hold the control key down and drop him into there? It's going to come up and say, hey, what do you want to call this? I'll keep it a rectangle. And would you like me to change the package? Yeah, I would. Thank you. Okay, so now the package names are the same. It's all chapter 7. Cool. All I did was just copy the rectangle from one source to the other. Okay, cool. Let's go back to our guy. And so, could I go in here and create me an array of rectangles? Well, of course I can. I don't know, it's 12 rooms in your house. Helps if you spell it right. Okay, so not much to see here, guys. Not much. Oh. Yeah. Sorry. I put parentheses rather than square brackets. My apologies. Okay. All right. So now this works provided you have a default constructor. If you don't have a default constructor, it's going to have to be one of these little funky things where you actually put the parentheses out here. Ugh, I don't like that, but I'm just saying. For this syntax to work the way we've been doing it, then, so, anything special here? No? It's just, you know, an object that happens to be in an array. Okay. So we're coming up on the 15-minute mark, and let's do what we always do.